Hello everyone, welcome to this LCP Delta webinar. I hope you are enjoying your morning so far. And thank you for taking the time to listening to our presentation on what we call the home energy interoperability utopia, which is basically a debate about the status of interoperability between home appliances, where we're at in terms of standardizations, protocols, API partnerships, the launch of Matter recently, which might impact things. We'll be talking about all of this in the webinar. It will last around 30-40 minutes, hopefully, but this is the presentation, so you can also ask questions, and we will either answer to you by writing in the software, or we will ask the question directly into the panel to answer the question. The webinar is recorded, which means that it will be available later on our YouTube channel. The slides will be made available as well on the PDF. So if you're interested, just let us know by email. And yeah, as I said, feel free to interact in the question box on the software. You should have a question to the presenter on the right hand side of the software. So don't hesitate to do that. So let me introduce you to the team on the panel today. So starting from the left, myself, Arthur. I'm Head of Business Development Europe at LCP Delta, and I've been working on the topic of interoperability pretty much for all my career for the past 10 years. I'm joined by my colleagues Ricardo, Sushong, and Hamza. Hi all of you. How are you today?
Hi, hello everybody. Yeah, happy to be here and be part of this discussion about this important topic.
Hi, Arthur. Good morning, everyone.
Arthur, good morning.
Hey guys, so this is a large part of our what we call our digital team at LCP Delta, looking at topics such as home energy management, connected home, energy insights, and how the market for these things develop. And the topic for interoperability actually is cross-cutting because it involves all the products that we're looking at in the home, and digitalization particularly is important for all of this. Before we talk about the questions that we are asking in the webinar, it's probably best to introduce yourself to what we are doing in these teams, particularly in the home energy management and connected home services, to give you some background. So in both services, we aim to provide you with the best-in-class data and insights about the European markets for these topics, which means a mix of databases, of sales of products, of competitor benchmark, reports on the market, analysis of new trends, business models, customer research, etc. And the topic of interoperability basically comes from the research that we are doing across this, because most of our clients have questions around what to do with protocols, with partnerships, with APIs, etc. But this is basically from the point of view of looking at how the market is developing, how it's growing, what are the main barriers, and how we could help accelerate the market development. So I'm just looking through some of the research that we have been doing for our clients in this space, and that's available through our subscription, both in the home energy management and connected home services. The agenda for today, first of all, a bit of context, which is always important when we look at interoperability, because numbers in the market are hugely influencing the needs for interoperability. Second, we'll talk about why it's actually critical in the home. Then a bit about the state of interoperability. So we have done a lot of research on looking at the products across Europe, what technology they are using, what protocols, etc. So we have gathered a lot of data on actually the trends in standardization, protocols, and openness, and we will share a bit of that with you. And the fourth point, probably the most exciting for some, the launch of Matter, which happened in Europe a few weeks ago. We were at the launch actually, and we discussed with a lot of the players there, and we will share our views on how Matter might impact the home energy space. And obviously the home automation aspect of Matter is very interesting, but The question is to what degree will Matter impact the European energy side of home automation? That's quite a big debate. We have a question already on whether we will receive the slides later on. Yes, you will receive the slides. We will share that with you after the webinar. And as I said, it will be recorded as well on our YouTube channel. So quickly some numbers, because we are currently facing a massive energy crisis. Customers are currently looking for solutions to help reduce their energy bills. And the first and potentially the easiest thing to do is to install connected climate controls or smart thermostats. Today in Europe, our research shows that there are around 15 million homes equipped with connected climate controls in Europe, and we expect this number to grow to 80 million by 2030. This could actually be bigger if governments realize that this is a huge opportunity to help customers save money and also on the carbon footprint. But basically, a lot of European customers will be equipped with this technology in the future. And the question of interoperability for that is, how easy would it be to connect smart thermostats and other products to heating systems such as heat pumps, boilers, underfloor heating, etc. And today, the story is that it's not that easy to connect to these heating systems, particularly beyond just switching on and off the heating system. The second huge trend following the energy crisis is the number of homes equipping themselves with large electric loads. And by large electric loads, we mean heating systems based on electricity. So that might be heat pumps, hot water tanks, direct electric heating, etc. Solar PV, EV charge points for those who have an EV and want to charge at home, even home batteries. So far in Europe, the market for large electric appliances in homes is relatively big, because we have quite a big electric heating market across Europe, and also air conditioning. So that's why the number is over 100 million in terms of number of homes equipped. But in the future, with the huge jump in terms of heat pump sales and EV sales, we expect that number to go to 180 million homes to be equipped with these systems, which means a lot of homes to be equipped between now and 2030, which means a quite big need for interoperability. And the third number to share with you is the number of what we call HEM systems. So for those familiar with our research, we define HEM as the optimization of energy flows within the home. Between this, we look at relatively basic, what we call appliance optimization, and also more advanced home energy management systems, which optimize a lot of things with a lot of values for the home, such as PV self-consumption optimization, dynamic tariffs optimization, etc. So far, the market is really small. It's really at the starting point of in Europe. We do expect the numbers to go up to 11 million by 2030, but actually this number could be much bigger because of the left-hand side of the slide here. So basically, the story is that customers will have a lot more reasons to make devices talk to each other in their home to help them reduce their energy bill and their carbon footprint ultimately. So interoperability is today a big barrier, and we are going to talk about how this will be evolving and what's the status of it today. So why is interoperability critical in the home? So as I said, the numbers are there and we are seeing huge growth, but there is an issue that there are so many different manufacturers, brands of products of large appliances in homes that it makes it quite difficult for customers to have one system that will work with any brand. So we have tens of heat pump manufacturers in Europe. The number of EV charge point companies is exploding, and it's a similar story for PV inverters, for home batteries, etc. And the challenge is that today, to make these appliances talk to each other, usually each appliance has what we call one API, which is one way to control the appliance remotely and to get some data. And for each combination of, let's say, heat pump and EV charge point, you need an API integration between the two, which means if you multiply all these numbers to make sure everything is compatible, we are talking about millions of API compatibility. And today, that's absolutely unrealistic to have companies and tech people work on so many compatibilities. And therefore, if I'm a customer and I have a brand X for heat pump and a brand Y for an EV charge point, it's very likely that these brands are not talking to each other. And therefore, I will minimize the optimization of my energy flows within the home, which is actually a shame, because this is what the energy transition is all about, is to minimize the cost for the customer and to reduce the carbon footprint of energy. So what we have done in this research, we have looked at a lot of the products available today in the market across Europe. We looked at heat pumps, we looked at EV charge points, PV inverters, batteries, etc. And we looked at what protocols these companies, these products are using, if they're using any. So open protocols such as EEBus, Modbus, etc. We looked at whether they are also part of bigger alliances. We looked at whether they have open APIs. An open API is something that, let's say, any company could use for an integration, and whether also they have closed APIs, so whether they don't allow anyone else to use the API without, for example, a paid-for partnership. And we looked also if they have their own proprietary protocols, which are really hard to be compatible with when you are a third-party player. So we looked at a lot of this data, and this is available in our databases. We did exactly the same for the HVAC industry, particularly looking at how to control the heating system. So today, if you look at smart thermostats, most of the time you will put a smart thermostat on a boiler, and you will be able to turn on and off the boiler. That's basically what you can do. If you look at the proprietary protocol of a boiler manufacturer, if you have access to the protocol, you will be able to control 100+ data points and control points, which means you will be able to understand how the boiler is modulating, how to optimize the efficiency, the temperature at different parts of the system. You'll be able to look at whether there is a fault in the heating system, etc. So having a better interoperability between the control and the heating system is critical. So we did exactly the same for the HVAC industry, and we looked at what protocols each product is using. There are lots of differences by country, as we will explain later. And yeah, this is available in our Connected Home Service database for this one. So this was a relatively long introduction. I will hand over to Sushang to talk to you a bit more about the complexity of interoperability and the trends for that, particularly in the home energy space. Sushang.
Yeah, thanks, Arthur. That's a really good summary of what we have been doing in the past few months in terms of collecting data, talking to people to understand what is the state of the home energy management interoperability today. If we come back to the story of home energy management interoperability, I believe everyone coming today understand what does it mean, interoperability. Perhaps we heard it a lot of times from the smart home IoT world, but why it is critical in home energy management and why it is so different in home energy management comparing to smart home. I think one key issue is that there's a lot more different types of players or stakeholders on the home energy management value chain. The first different types of players are the energy market players. And you can think about electricity system operators, some flexibility aggregators, energy suppliers, and some managers of the energy local community. What we think is that interoperability can benefit all types of players on the value chain. Think about today, residential energy assets. We're talking about EVs, heat pumps, batteries, PVs are growing faster and faster every year. There are more and more cases that residential assets are being involved in the energy market because it's becoming such a bigger load than before that we need to keep the network balanced, and that's why the role of residential assets is becoming more and more important. But think of an energy supplier who want to launch a demand response campaign with its customers, but when it comes to the recruitment of the of the people who cannot participate in the demand response campaign. If everyone having a heat pump from one company, having an EV charge point from another company, that could become a really big issue for the recruitment because of the lack of interoperability between all those different brands of the products. So we think that energy market players can definitely benefit from the interoperability of the energy assets. And talking about the assets, a lot of the asset OEMs and the control OEMs, in terms of the control of those assets, also thinking about how can we do to improve the customer experience and to save the customers' energy bills, because we have so close a relationship with the end customers. That's why interoperability can really help these manufacturers or control providers to help them to change their business model from product selling to some services in order to provide more benefits for the end users. And finally, I think there are also some other types of players on the value chain, including some housing developers or some facility managers who want to use a home management solution to, first of all, manage their assets and then to provide extra value to their customers. It's not only the players on the value chain can benefit from interoperability, but when we talk about the end users, they can also unlock a lot more value if we can achieve what we call interoperability in home energy management. So you can still do a great job on your own platform if the kind of home energy management systems is sitting between the OEMs and its partners, but it's never going to be a massive market because there's no way that you can access to another company's product and another company's platform. But imagine a world that we can have data available via APIs or open protocols from every different types of companies, OEMs in this world. We can at least to provide some energy monitoring. Either if you can show at the next column there, some energy monitoring and insight services to help the end customer to understand their energy bills and how their behavior could change their energy consumption bills. If we can add a little bit more controls, such as turn it on, turn it off, we can do some automations to better save the energy bills. And then we can also do some automations to help to self-consume more electricity produced by your sort of PV on your rooftop. And if we have more set points and more controls available without APIs or open protocols, there are a lot more value streams that we can develop to create more value for the end customers. We have done more quantified analysis for this chart, but the idea here is really to show that the cake could be bigger if the OEMs could open their platforms. And the only question is really how to share that benefit and that value creation with the end customers, with your partners and the OEMs themselves. So all good things or amazing things could happen if we have interoperability. But the situation that is never going to be an easy work to do. I think this meme has been used several times by many people, but we want to remind people again that the situation is that there might be 14 standards in the market today. But if some people came together and say, let's create another standard and have everyone using that standard, very likely we will end up with 15 competing standards with each other rather than everyone using the same one. Think about the world that we're living today. We have English, this is such a simple language to speak, but still not everyone is using it. It's exactly the same happening in the home energy management world, and we haven't got something like English that is simple and easy to apply. And that's why it's super difficult to convince everyone to use the same standard if it's just market driven rather than pushed by any regulation or policymakers. So if we don't have a common language to be talked by everyone, what do we need? We need a translator who understands the different types of language in this word and then do the translation between different assets and different levels of controls. Look at all those complicated keywords surrounding a home energy management systems. Today, because of the lack of interoperability, a lot of the home energy management system integrators are actually taking the lead of kind of integrating different assets, creating partnerships between different OEMs and different stakeholders, like I mentioned just now, and to achieve the kind of either energy cost saving or system services values to the end users and to the electricity system. And what we have done at SAP Delta is that we have created an actor database really to look at different players in the market. And one of those really key category of the players are the integrators who are really taking on the job of achieving interoperability in the market today, talking to everyone and try to make the control of everything seamlessly. And now we're going to talk about the state of interoperability in Europe today. So more closely to what kind of protocols and what kind of standards we're really talking about. This is really a summarizing slide that we have summarized all different types of protocols, communication protocols being used for different types of products. If we start from the bottom, products, I think people may not be, should be very familiar with those different types of protocols, like we have the SG Ready in Germany for heat pumps, it's OpenTherm, what they use in the Netherlands for gas boilers, solar PV and batteries, where Modbus, Sunspec Modbus is very widely used. For EV and EV charge point, there are quite a lot of OCPP, ISO or IEC standards being applied. Also smart meters, there are some power line communication protocols being used. There, on top of these, there are also some cross-cutting integration protocols like eBus, Modbus, Matter from a home automation point of view, and Econet, a Japanese protocols which is adopted by several Japanese HVAC manufacturers. And there are also some specific protocols being used for different applications. So for example, some of the local data transmission protocols are more often used for home automation, and there are also some energy flexibility specific protocols like OpenR, like S2 being used for simplifying the flexibility services. And like I mentioned, we have to connect everything to the internet. That's why you need Wi-Fi. Also, you need the data transmission. That's why a lot of the protocols that you're seeing for the home automation applications are also used for data transmission. So that's really an overview of all the protocols in the market, but that's not the only thing. We also have cloud APIs, which is basically an interface between different cloud platforms in the market, trying to achieve the same applications for interoperability. And I think next step, we're going to have a zoom into some critical asset controls. And I hand over to, I don't know, Ricardo or Arthur.
That's to me. So yeah, thank you for that. So as Soshan just mentioned before, there's several many protocols used at a different layer in the energy industry. And what we want to talk about in this slide is, want to give the perspective from particularly on the heating and cooling industry. So what we can see in this slide is on the right, we can see the protocols that are mostly used in this particular industry by major HVACs in Europe. The idea basically it is to show that proprietary protocols is the most common used today. And by what we mean by major HVACs of heating and cooling, we include gas boilers, air-based and hydronic heat pump, the AC, electric and storage heating, and so on. So we can clearly see that the most common is proprietary protocols. Such I mentioned before in the few slides, is this can limit and is limiting the the potential services around the revenues and other offerings related to these particular products, as only the OEM has control or full control of the product, and can limit the market evolution as well. Then the second most common one is Modbus, but however, Modbus can be widely used in many different assets, and it's an open protocol. Most of the time, the HVACs use either a modified version of it or use proprietary commands to improve it. So it also offers kind of a little bit of basic communication and control by other third parties. And then we can look at there are much other protocols, such as OpenTerm or SG-Ready that it was mentioned before, or even EBUS. But the case of these protocols is that they're very market dependent or very localized. So Sasha mentioned as well another one used particularly in Asia and Japan. OpenTerm can be widely used, or it's widely used, but mainly in the Netherlands. Then we have SG-Ready and EBUS widely used in Germany. So the idea here is that at the moment it is very complicated to develop a holistic solution, because you will have to face if the product you are targeting or the asset, do they offer a proprietary protocol, or is you have to look at what market is being launched, and then you will have to comply with certain protocols. So it is a bit complicated at the moment.
Yeah, so basically, Ricardo, as you said, the picture you can see on the right is a European overview, but actually this will change very dramatically from one country to another in terms of how widely some protocols are being used and some are not. Particularly, there are lots of differences between Germany, Netherlands, and the rest of Europe. There are some questions in the chat, so I'm going to ask one now from Taco. What are the dominant protocols for heat pumps, and do you see a difference with traditional gas-fired heating systems? So, Ricardo, maybe a question for you on this one.
Yep. So for heat pumps, it's the most common we've seen is proprietary protocols and Modbus. But as we said, it will depend on the market, but actually definitely is most proprietary and Modbus for heat pumps.
Yeah, so basically no OpenTerm in heat pumps, lots of proprietary and different ones. So yeah, it's very complicated for someone to build a thermostat compatible with a boiler and then with a heat pump, which again proves the need for interoperability even more. Moving on to the EV and EV charge point slide, Hamza.
Yes, thanks, Arthur. Well, if we look on the EV and EV charge point market, we have interoperability depends mainly on these four entities that needs to speak and to communicate with each other, and in order to ensure the full calibration and to provide the best experience for the end user. And for that, there is in the market several protocols and standards that deals with different areas in the EV market. And for example, for the communication between the EV and the EV charge point, we have these three protocols, but with the CHAdeMO, the Japanese protocol that is being phased out in Europe, we can see the rollout of the latest version of the ISO 1 that allows advanced communication between the EV and the EV charge point, and that supports multiple services compared to the widely used IEC, such as smart charging functionalities and bidirectional power transfer, or V2G, or vehicle to grid. And for communication between the EV charge point and the charging management system, we can say that the OCPP is the most common protocol. It is widely used and adopted by most of the EV charge point OEMs, but which is great and perfect. But the problem with this protocol, that in practice, the integration of the protocol is more complex, since we can see that many EV charge point manufacturers are extending their proprietary protocols on the OCPP, which increases the complexity of integration and hinders the interoperability in the industry. And for communication between the charging management system and the grid, we have mainly this OSCP protocol that mainly communicates some 24-hour forecast on the availability capacity on the electricity grid that allows the charging management system to avoid the peak loads and to avoid overloading the grid. And we have also between the EV and the charging management system a communication that can be done via cellular networks that can be used for communicating some basic information such as a battery level or like the nearest charging station in the area. And for communication or for flexibility and communication with the grid, OCPP can be used in conjunction with the demand response standard OpenEDR, which makes it easier for utilities and system operators to communicate with the EV charge point, but is still in early stages and not yet much adopted by the EV charge point manufacturer. In general, we don't expect that we will have just one single standard to solve all the different problems in the whole EV ecosystem. I don't, at least not in the near future, but there is like a new IEC standard, which is IEC 63110, that is being developed to standardize the protocol for all these four parties, the EV charge point, the charging management system, and the grid. And we expect that OCPP is going to form a foundation for this protocol. However, since the standard is still under development, it may take some years before we see any uptake in the industry on a larger scale. To conclude on this, we believe that since the EV market is relatively new and in its early stages, interoperability relies on all contributing parties, so including the EV charge point manufacturers, the energy network operators, and the policymakers that must work together to ensure its future success. And I think that's it for this part. I'll hand that over back to you, Arthur.
Thank you, Hamza. So you can see that there is already a quite complex environment just in one part of the home energy aspect, and understanding all of this is actually quite critical to make sure that companies make the right decisions in terms of protocols and interoperability. Sushang, the question of who wants open APIs and who doesn't, what do you say about that?
Yeah, very good question. We talked to many different people in this industry about APIs. So basically, the idea of APIs is let's stop talking about a language that we talk to each other. Let's have our two platforms just communicate via the cloud. You send me a request like temperature. I give you a set of data like every kind of the setting temperatures, the real-time temperature, everything related to temperatures. Okay, sounds really good, but as you can see, there are pros and cons of this process. Is it really sustainable? There's still a question mark there. And the orange box will be the pros, but the gray box will be the cons. The most cons that we received are really from the integrators who really integrate the APIs and provide it to the end users. They told us that integration and customization of APIs can take a lot of resources to integrate. Sometimes problem could occur when internet goes down in the homes of the clients. Availability and the data quality of APIs today provided by the OEMs are still very different, one comparing to another one. And once there's an API updates by the OEMs, and they need to put resource and time to update that on the end of the integrators platforms as well. If it's just several companies, that is okay. But if you're talking about hundreds of companies from different industry, that's really a pain to update all the APIs. But the good thing is that the API today can already help them to provide a hybrid system. So on top of the protocols that we have mentioned, some API can help them to integrate more products. And already there are some of the OEMs providing APIs, which is good news for those integrators. If you can move, yeah, Arthur, can you move to the rest of the two types of companies? I think asset manufacturers and some energy suppliers that we have asked that really they really like APIs because from the asset manufacturer point of view, they can still control their data. It's kind of like customized offering to third parties, so they can block any suspicious use of their data by third parties. And of course, to develop a home energy management solution, APIs can usually provide more granular data. Like some companies are offering a premium model to provide more granular data, more details to the third parties, while open protocols, because of the concerns of the OEMs, they may not be able to provide all the data available. The only downside is that developing API from scratch is very slow for OEMs. So there are a lot of companies helping those OEMs developing APIs. But the only question is really like, if we use APIs, it's really easy to share the data from one OEMs to third parties, but there's no way that we're able to control the products from the other OEMs if the OEM itself want to become a home management providers. So for companies who only want to share data to be compatible with those platforms, okay, great news. But for companies who want to integrate APIs or data from different platforms, it is still a lot of work to do the integration. And badly for many energy suppliers who only want to do kind of like energy saving services, I think APIs is still a very useful tool for them to easily control some of the products from their partners.
So thank you, Sushang. So the last point, and we've had a few questions in the question box about Matter. So yeah, for those of you who don't know about Matter, this is something that a consortium of Google, Apple, Amazon have started a year or two ago, and the idea was that they would stop compete for interoperability and create one common ecosystem where all devices in homes could talk to each other. And the protocol was officially launched in Europe a few weeks ago. And based on that, we talked to companies, we analyzed what's happening, and we wanted to share a bit, first of all, what it is exactly, what it can do, and our views on what it will do in the future. And with this, I will hand over to Sushang, who can explain to you a bit more. Well, first of all, what Matter says it can do, but also our analysis on that.
Yeah, so basically, Matter is created for the smart home automation as a priority. So it's supposed to be simple because a lot of large parties, including tech giant like Apple, Google, Amazon, trying to simplify and set an agreement how to control all those different smart assets at home. It is supposed to be interoperable. Everything is based on thread, and if we have an agreement of the language we talk, yeah, they're supposed to be interoperable and reliable because it's a local communication system. Of course, it will be connected to the cloud via Wi-Fi or any other data transmission protocols, but it's based on thread, very reliable, and it's supposed to be very secure because most of the big parties there are very specialized in the security of the IoT system. So everything brilliant for home automations. But when we come back to the point of view of home energy management, what we have seen is that there will be more potential actually from the home automation perspective, which is because most of the products that is compatible with the protocol today are smaller gadgets like your smart light, your bulb, for example, your doorbells, the security system, some cameras as well. A lot of use cases for smart homes rather than home energy management, which require some larger energy assets, including your battery, your PV or PV inverter, your heat pumps, and your EV charge point and the EV, for example. And so far, there's really a lack of those larger energy assets and companies in the membership of Matter. And talking about membership, the use cases development is really driven by the members of the Matter Association. And we know that energy management is one of the over 30 use cases being developed right now. But in terms of the priority, it's really driven by the purpose and the need from its members. So if we can see more and more larger energy asset members showing up in the list of the Matter aliens, I think definitely there will be more development on home energy management in the future. So yeah, that is really from a home energy management point of view. What we have expected that it's unlikely to have a short-term impact in this market, but everyone is watching it to see if we can really succeed in the smart home industry and if really achieve that kind of interoperability for smart homes. Yeah, why not have the same initiative for home energy management as well?
So basically, Sushang, short-term impact on home energy management very unlikely to be impactful at scale, and therefore the next few years of managing appliances in the home will probably have to be without the help of Matter, which is a shame. Ricardo, can you tell us what you think will be the impact of Matter on the link between controls and heating systems, and I guess particularly boilers and heat pumps? Is there any world in which the barrier for interoperability will go down thanks to Matter for this?
Yeah, sure, thanks. So yeah, as mentioned, as Sushang mentioned before, yeah, this Matter we see in the short term more impact into home automation. We've seen already many companies offering this type of controls already being part of the alliance or even already been certified. The way we see in the let's say midterm or how this will impact in the connected climate control is meaning that basically Matter would allow to control your, let's say, smart thermostat from different type of ecosystems. As you mentioned, there's 3 big companies there, and that way you might be able to control your let's say your smart thermostat from your Apple device or Google device or Amazon. So that could be like a potential link, and then you can control your heating system. That's how we see it will be or is happening or will start soon to enter this kind of connected controls ecosystem or market. After that, it's going to be, let's see how the market evolves. As Sushang said, this is driven by the companies. We talked with many HVAC companies. They mainly all of them say that they want to be part of this Matter movement, but their reality is, let's see how until which point they're gonna use this or leverage this interoperable protocol to access other services or even be useful. Yeah.
Okay, thanks, Ricardo. We have a few questions on this debate actually. So one is around how long we think it will take off in our space. Well, depending on what we talk about, climate controls or energy management, probably a few years, if not longer. That's our view currently. We are happy to review that thinking at some point. But so far, with what we know, what we can see in the market, and the reaction from manufacturers, this is what we think. So the short-term impact is really going to be negligible. Right now, we have a question or more of a comment on whether we are aware that more than 10 energy-specific work groups are already on the way for Matter, and Google, Amazon, and others are working on prioritizing those pieces of work. So yeah, we are aware that there is a lot of development being done behind the scene. The issue we see is that the focus of the tech giants like Google, Amazon, etc., is primarily in the US market, and the US market is quite different from the European market for PV inverters, for heat pumps, etc. The protocols are quite different. The manufacturers can be a bit different, and also there is a massive fragmentation of the market, which means it is hard to replicate what can be done in the US to Europe. And we we honestly, talking to the manufacturers so far, we don't see them completely opening up to such protocol yet. And if they do so anyway, it will take them time to realize that and to actually do it, because technically speaking, it's not that easy. And these manufacturers, it's not in their DNA to develop protocols and digital stuff. So if they can be convinced, yes, it can help the market. So far, we don't believe they are convinced, and we don't believe they have the capabilities to do so. Therefore, we have a relatively pessimistic but realistic view on this. The questions on whether we have any EV charger manufacturers committing to Matter already. I don't know, guys, if you saw any, but I guess some have shown interest into this. Again, our database will tell you that in more details, as we have looked at a lot of the EV chargers across Europe. Do we think manufacturers want Matter, or do they also see it as a risk? Will they be reluctant to implement Matter? Honestly, we have a big experience, especially in the HVAC industry, from our Connectum service, and yes, I truly believe that a lot of the manufacturers, especially at the board level, still find it hard to believe that there is a business case for opening up and connecting to open standards like that. The reason is they don't necessarily know what to do with the data, how to monetize the data, etc. And therefore, opening up might be seen as a risk to enable third parties to control their products. And this might be a wrong way to think about it, but by talking to companies, we realize that this is the case actually. And unfortunately, there are old industries which are hard to move, but hopefully things are changing, and perhaps a global movement like Matter might help. But again, time will tell whether these companies will actually adopt it, and if they will be very proactive at promoting it as well, which is a big difference. So anyway, just to remind you that as we described, we have done some studies and databases around these topics in both services. So the Home Energy Management State of Interoperability 22 has been released last month. So that's a report analyzing pretty much everything we have talked about in this webinar. This comes with a database looking at 130 plus products in the market, detailing which protocols, standards, APIs they are using. And on the Connectum side, we are releasing the HVAC State of Interoperability 22 in the next few weeks, and this will also come with a database looking at protocol standards used by the HVAC industry. So don't miss out if you are subscribers, and if you are interested in getting access to these data points and these reports, please let us know. And finally, it's time for us to tell you thank you for attending, taking the time to join this webinar. We hope that you learned a few things, or it made you think about this way in a bit differently. If you want to continue discussing this topic with us, again, as you know, we are really open to having discussions on that. It's always interesting to learn from each other. As I said at the beginning, the slides will be given on the PDF, and the recording of the video will be available on our YouTube channel. So you'll be able to share it with colleagues if you want. Thank you, Ricardo. Thank you, Sushant. Thank you, Hamza, for your presentations. And thank you, everyone, again. I hope you have a great day. Enjoy the rest of the week, and speak to you later. Bye-bye.
Thank you, everybody. Bye.
Thank you, everyone.
Thank you.